Hi everyone. Um, this is the last little bit that you guys need to know about before pretty much we're done for this level 2 internal. So these are like the main ideas you need to basically understand, even though all you're having to do in the actual internal is write equations. So I'm going to start with the easier idea. So the first one is ammonia when it's in solution. So this is the symbol for ammonia, and you've been using it for the last few days anyway, so you should know it. It's NH3. Now, ammonia is found in a bunch of things, but in general it's used in cleaning products. Now, all solutions of ammonia actually don't just exist as this molecule by itself, because what happens is it's always diluted with water, so when there's water present, it can undergo a type of reaction called an acid-base reaction. So ammonia is a base, this thing here is a base, and the definition of a base is it means when it's placed in water, it will accept a hydrogen ion. So what it means is that water gives up one H to the ammonia, and you end up forming this product here, NH4+, which is the ammonia ion, and hydroxide ions. So those hydroxide ions always form when bases react, so OH-. So in a realistic situation, when you actually have, say, a beaker of ammonia, so here goes your beaker of ammonia, there's a bunch of things present. So there's a little bit of this, a little bit of this, a little bit of this, and a little bit of this. So you may have seen in the past some reactions where they have an arrow going in both directions. That means the reaction is in something called equilibrium. Now we might look at what equilibrium actually means a bit later on in the year, but at the present time what it means is you have some of everything in your actual equation. So you've got a bit of this, a bit of this, a bit of this, and a bit of this in your actual solution all at once. Okay, so as soon as you have ammonia, you actually have some hydroxide ions, some ammonium ions, some water, and some ammonia ions. Now, in your reactions, when you've been doing them, when you've added a small amount of ammonia to something, so say for instance, one of the reactions, I'll show you on the graph here, one of the reactions here that says you need to add ammonia could be this one here. So you've got a precipitate that disappears. You get your new sample, okay, of your unknown, and you add 2 drops and then excess of ammonia. And it says, we're going to pretend we have the zinc ion here, it says a white precipitate forms and then that it disappears. That white precipitate that actually forms is exactly the same white precipitate that would have formed up here if you started with zinc to begin with. So you added sodium hydroxide and you formed zinc hydroxide as the white precipitate. Then you did all these other things, and then your next step to identify zinc was to add 2 drops of ammonia and you formed another white precipitate. That white precipitate is actually just the same thing. It would be zinc ions, so Zn2+ ions, those are the ions we're using, plus hydroxide ions that have come from the ammonia solution. So there's some hydroxide ions present in your ammonia solution, that's where they've come from, and you form ZnOH2. So when you see the initial adding of ammonia, and if any white precipitate forms, that initial addition is actually these hydroxide ions being added. So any precipitate that forms from adding ammonia is the hydroxide ion that's precipitating. Okay, so you've got, oh, sorry, I just balanced that equation there. So you've got 2 hydroxide ions. I'll give you one more example. So another one that forms, and here goes another one that forms with the same idea. So you've got copper ions this time. So you've done your practical and you've worked out what the ion actually is. It's copper. But then at this stage here, you have a new sample. You've added 2 drops of ammonia, the solution, and then you add excess. Initially in this reaction, a blue precipitate forms, then a deep blue solution confirms that it's copper 2+. So the blue precipitate that forms initially is actually the same blue precipitate that you would have got here when you added 2 drops of sodium hydroxide to the initial thing here. So you added 2 drops of sodium hydroxide, you got a blue precipitate. When you add ammonia, you get the same blue precipitate. So the reason why is because, once again, the copper 2+ ions, so Cu2+, are reacting with OH minus ions, that's from the ammonia solution, and they form CuOH2. Alright, that's the key idea with the whole ammonia thing. So that's why I left it till the later stage to actually explain it, because I knew it could be confusing. The other thing that you need to know is about complex ions. Now I've written up notes for you guys on the complex ions. There are about 7 that you need to know. Now, all of the reactions where you end up with a colourless solution forming or a coloured solution forming are forming complex ions. So, for instance, over here we have a precipitate that disappears. That disappearing precipitate is forming a complex ion. Now, over here we've got the same thing again. You formed a dark red solution. Here we formed a deep blue solution, and then here we formed a colourless solution. So pretty much anything that redissolves, so one redissolves, or anything that forms a colourless or a coloured solution is a complex ion. Alright, let's just jump straight into an example of a complex ion reaction, and I'll show you all the 7 that you need to memorize in a second. So I'm going to pick the copper one again. So you start with 2 drops of sodium hydroxide, you form a blue precipitate, you have a new sample, add 2 drops and then excess of ammonia, you get a blue precipitate, and then a deep blue solution confirms it. So I'm going to write out all the reactions you would need to for that one. So first, you choose your copper ion, so you write Cu2+, plus initially you're adding sodium hydroxide over here, so we need to add hydroxide ions to this, so OH, and it says here that we form a blue precipitate. So we're going to write our first blue precipitate, so CuOH, and you would write all your observations down as well. Very key, you must balance these equations. If you don't balance these equations, you'll lose merit and excellence points on this one. So this is your first one. Now if I was you, I would identify them as solid, aqueous, and aqueous for each of these ions and solutions. Remember, complex ions are solutions, so they will be aqueous. Right, the next step says new sample. So new sample means you have to write another equation, even if it's the same one, and it says add 2 drops first and then excess of ammonia. So we'll just do the 2 drops stage first. It said it formed a blue precipitate. If you only add 2 drops of ammonia, you are forming, again, the hydroxide ion. So you need to write a second equation for this. Now the reason why you need to show the second equation is to prove that you understand that adding ammonia actually means you're adding hydroxide ions to start with. Okay, I can't put the Q in there. Oh, there we go. Alright, and then we've got one last equation to write for this one. The last step says add excess ammonia, and then that it forms a deep blue solution. So the very last equation that you need to write is the complex ion equation. So you do the same stuff as you usually would. We start with Cu2+. This time we're adding lots of ammonia. If we're adding lots of ammonia, you add NH3. Okay, this is the actual ammonia now that we're adding. And the complex ion for this you'll need to memorize. It is Cu bracket NH3 4 square brackets around the outside and then a 2+ charge here. This is not balanced yet. I've got 4 ammonia ions here, so I need to balance it with 4 here. And you might want to put in these states again here. These ones will all be aqueous. All the complex ions will be aqueous. Alright, sorry, I had to write over a picture there. So this would be all the 3 equations you're required to write for a complex ion one. Now I'm going to give you a list here of all the complex ions you need to know. Actually, no, I might just point them out and I'll give you them for notes. I'll give you in the notes that I give you, I'll show you the complex ions you need to memorize. So here they go. This one here shows you a precipitate disappearing, so that's a complex ion. And it says you're adding ammonia to this one, so if you're adding ammonia to it, after you've got your complex ion forming, you are adding Zn2+ plus ammonia, the ion, to form your complex ion with ammonia. Also, if you look up here, there was another precipitate disappearing. Right, this isn't the best color to color in with. That also formed a complex ion. But in that case, we were adding excess sodium hydroxide. So the complex ion is a hydroxide complex ion. So I'll just briefly show you. It's this one. Remember, there is only 4 of these, only 7 of these that you need to remember. So the complex ion that forms on that step there is this complex ion here. Right, so there's that one, there's this one. We've got a solution here, we've got a solution here, we've got a solution here. So that's 1, 2, 3, 4, 5, and there's a couple on this page here. One forms when you have a precipitate disappearing here. Alright, there you have it. Those are all the complex ion ideas and ammonia ideas that you need to understand. Here goes just a picture of the colours that you'll form here. This one here is the iron thiocyanate complex ion. So that deep red colour, that is the iron thionate colour that forms down here. Here we have the copper hydroxide as a precipitate. This is the copper with the ammonia complex. This is the deep blue colour of the solution I'm talking about. Now here goes the two that people often get confused. This is the iron hydroxide precipitate. So iron 2+ hydroxide. This is orange. This here is the silver precipitate that forms when you add hydroxide ions. So this is brown. Orange, brown. And here goes just another picture showing you, that's the fake blood colour we were talking about. That's it when it's undiluted. If you dilute it down a little bit, you can see that it looks more red, like in this picture here. And then when you dilute it heaps and heaps, it starts to become more orange looking. But you're going to say deep red in your colour change for this one. Alright, there you have it.